Welcome everybody. Today's lesson is about nth roots. Now in your math careers you've talked about square roots and maybe even cubed roots. But since we have large exponents, we should be able to have large roots. So that's what the root of today's lesson is. Let's first look at what a cubed root is. A cubed root is the solution to a problem. For example, t to the third equals x. I would take the cubed root of both sides, as shown here. Another way to write the cubed root is x to the 1/3 power. The exponent theorem says that I could either write the root as a square root or as an exponent 1 over the root. So for example, instead of writing the 5th root, I could write x to the 1/5 power. Now, let's talk a little bit about the numbers of roots. So, every positive real number has two possibilities. Either the exponent could be even or the exponent could be odd. If n is even, there are two real roots. If the exponent is odd, there's only one real root. I've drawn the graph of the even and the odd functions to help illustrate this. If you notice, even functions that are in the shape of a parabola always intersect the x-axis twice, giving us two solutions. Odd functions, on the other hand, only intersect the x-axis once, giving us only one solution, or root. 0 has only one nth root, and we know that is 0. So, looking at example 1, we'll use this table to help us decide how many possible roots each number has. Now, for part A, we are looking at the 5th root of -27. So, since 27 is negative, I'm already looking at the negative real number section. Since 5 is odd, I bump down to the odd number section, and that shows me that there is one real root. Next, I look at 18. 18 is a positive number. I notice that 6 is an even number, so that should give me two real roots. C. 44 is even and positive. 7 is odd, so because 44 is positive, 7 is odd, I know there is one real root. Lastly, I look at -18. -18 is obviously negative. If I try to take the 8th root, I cannot take the 8th root of a negative number, so there are 0 roots. Now, on your own, use the table labeled Number of Real Roots theorem and try to find the possible number of roots for A through D, and then check your answer. You should have found that there is 1 real root for part A, 2 for part B, 0 for part C, and part D has 1 real root. Alright, moving on. Let's try to evaluate some of these roots. Remember, if you see the exponent as a fraction, the denominator of that exponent tells me the root. So, for example, 81 to the 1/2 is really just the square root of 81, and we know that to be 9. Now, the second one, this is -16 to the 1/4. This is a negative number, and I'm trying to take an even root. This is not possible. So there is no real root. Okay, third one, I've got 1. I'm trying to find the 8th root. Well, if I have 1 as my base, the root will always be 1. Lastly, I've got -32, and I'm trying to find the 5th root. So I have to determine what number to the 5th power will give me -32. I know that number to be -2. Now, you may also enter this into your calculator when we get further along. We'll talk about that when we get there. On your own, try to do the next set of examples and then check your answer. You should have gotten -5, 2/9, and 7. All right, let's flip to the back. We can use our knowledge of roots and also solving equations to do some more complex work with nth roots. Now, to solve c to the 1/2 equals 5, I want to step back a second and think about our power rules. Remember that a power raised to a power tells me to multiply the exponents. So, if I raised c to the 1/2 to the 2nd power, my new exponent would be 1, or just c. Since I squared one side, I have to square the other, so my final answer is c equals 25. Let's look at another one. I need to solve b to the 1/4 minus 4 equals 4. I first need to get b to the 1/4 by itself, so I'll add 4 to both sides. I'm left with b to the 1/4 equals 8. Now, to get b all by itself, I'm going to raise 1/4 to its inverse, 4. I need to do that to both sides. So my final answer is going to be 8 to the 4th, or 4,096. All right, you give it a try. Try the on your own problems and then check your answer. You should have gotten p equals 160,000, and that's from raising 20 to the 4th power. For the second problem, you should have gotten r equals -64. You need to divide both sides by -10, and then raise -4 to the 3rd power. All right, last question. We want to try to use the graph of y equals x to the 8 to estimate the real roots of 3. So, what I've done is I've graphed two functions to the right. I graphed y equals x to the 8, and I also graphed y equals 3. To determine the roots, we'll look at the intersection of those two graphs, shown by the black dots. To actually estimate the real roots, I can use my calculator. Now, I'm going to use the second trace function and find intersection. It'll ask for the first curve, and you should put your cursor on the parabola. It's going to ask you for the second curve, and you can put the cursor on your line y equals 3, and it will zero in on the intersection point. This should be approximately 1.15. If you do the same thing on the other side by putting your cursor on the parabola, your cursor on the line, you would get -1.15. This is the same number you'd get if you had taken the 8th root of 3 on your calculator. To do that, I would enter 3 to the 1/8 power. And again, this gives you approximately 1.15. There you have it. That's all you need to know about nth roots for now. We'll discuss further in class tomorrow. We'll get an opportunity to improve your craft. See you then.